Hello, I'm Ed Simmons from Brook Advisors. We have an exciting panel for you today talking about capital markets data transformation. I'd like to introduce our panelists here. Sourabh Dhawan, Senior Vice President at Arcesium, where he leads a team of technical solution architects specializing in data platforms and enterprise data management. Sourabh works closely with clients across capital markets. At Arcesium, he's focused on helping investment firms turn data into a competitive advantage through scalable, resilient solutions. Oleg Komissarov is a principal consultant at DataArt in product solution and architecture. He's the lead for DataArt's new AI Lake Accelerator framework. He brings over 20 years of hands-on experience in data and transformation. So
Oh,
let's get started. Uh, Well, everybody wants to do AI these days, and people have a bunch of disparate systems that don't communicate well, and everyone is nervous about how to make these systems talk to each other and how can I provide data to do AI. How would we think about that now, Sarab?
Yeah, so in my view, Ed, times have changed. There was a time when many years back, it was one monolithic build that you had to do to get your data platform up and running. Times have definitely changed now. It's no longer like a multi-million dollar investment. It's a much smaller scale at which you can really develop like a premium data platform which can serve for your needs. The cloud technologies are really have become superior in this on this framework. So they offer you tools and capabilities to really be able to design a data platform that suits the needs of your organization. So it's like it from a place where it was a multi-million, multi-year project to come up with like something that can even be close to managing your needs. It's a much smaller months of investment with much smaller dollar cost to it. So there is a definite change with the technology the cloud providers are offering today. You need to basically get the right tools based depending on your need. There are a lot in the market, and once you stitch them together, you get the real class data lineage, data catalog, data quality, which can be like the baseline that helps you build on top of it around the AI and other stuff that you're talking about.
Oleg, could you talk to the fact that nowadays you don't necessarily have to replace your legacy infrastructure to use one of these modern platforms?
uh, right. So many of the modern solutions and infrastructures, they are serverless, so you can um, enable your new data infrastructure and AI capabilities by utilizing serverless frameworks and solutions and using them in parallel with your existing infrastructure. So instead of replacement, you can integrate and get data in using different methods, and yeah, reduce your technical debt.
Yeah, one of the things I would add is the other key to serverless platforms is operational costs. While they can be expensive to run when you're actually using them, they cost next to nothing when you're not using them. And this is a big advantage in terms of delivering value before you spend money. So Rob, we talked about cloud technologies providing solutions i- and via services, but isn't there they have all these different products? Isn't kind of you know uh, a lot of different things that don't necessarily work together? How do you view these in terms of taking a overall holistic platform view?
So that's a good question, Ed. So I think that again, there are many tools that exist in the market that these cloud providers provide, doing similar things. You need to choose them wisely. That's important. And when I say you need to choose them wisely, you need to consider certain aspects of how you define what is best suited for you. In my view, the user base is the most important. People or the group that is going to be using the product eventually gets to define like how they would set up and how they would be using the tool. So that is one of the more or most important considerations when you're defining like how you stitch these things together. The user journey is really important. The users needs to be brought in and their views needs to be taken into consideration well in advance. At many times, like there are cases where organizations tend to have this as a more architect view or the design of the engineering, and they lose the focus on the user group. So that is, in my view, where you might tend to fail in some of these initiatives. So like the tools are there in the market, but knowing them, which one to use, which one to knit together, they can offer like different values. Some are more to work on scale, some are more to work on lower volumes, but they tend to provide better outputs. So there are different classifications of these tools. The what you tend to choose is more on the organization needs and how the different groups needs to be structured, who ultimately will be the consumers of this overall product.
Yeah, and what's really interesting here is once again we go back to the pay by the drink services model, where in some areas it may not be worth fighting over two groups. Let them each have the tool they want. In other places, we may want to standardize on one tool, but for some of the stuff, you can basically say if you want to do Tableau or Power BI, we'll support both because once again, the cost for two may not be that more in terms of the cloud. Oleg, can you talk about how you put this stuff together? What's your methodology for integration?
Uh, right. So essentially, nobody likes expensive and long projects where you have to integrate software because, from business standpoint perspective, it does not add any value, only adding cost and delaying your business deliverables. So what we always recommend is to look at the technologies that provide open standards like open lineage, SSO, or open standards for data consumption and storage. If you use open standards and protocols, it would be way easier for you to integrate without creating custom code. And the second principle is take a look at native integration. So if you are building your solution partially or fully on any data provider, just look at the integrations that supported by this provider out of the box. So for example, AWS warehouses natively integrated with storages and other tools, which makes your integration job basically a configuration as opposed to custom development. But always have also scale in mind, right? You can put together small prototypes quickly, but forecast your workloads and think about how your integrations and components work in the future 1 year from now. 1 year from now with real production workloads.
Yeah, one of the things I really like about this type of architecture is, for example, something like Glue. If you're using Glue from AWS, and as long as you don't over customize it, when Glue improves and they have a new version of Glue, your system improves. And this is kind of the reverse of the old technical debt problem where your stuff deteriorates over time. This actually is a platform that's alive and breathing and in some ways maintained by other companies, particularly the hyperscalers. So to me, it's very interesting with these service and SaaS-based solutions. You can really improve over time your platform over time without maintaining a big central team. When I built these things in the past, a long time ago, they would cut the budget of the central team after you built it, and you would struggle to maintain internal products. And here, that is kind of not as big an issue. So, Rob, you want to comment on that?
Yeah, that's true. So it's more about keeping yourself up to date, what's happening in the market, what these tools are offering, and if you look at it right within the cloud providers itself or within these companies that offer these capabilities, they have a race to be ahead. So as you said, like there are more and more capabilities being added in these tools. You basically inherit it for free. You basically just need to be up to date with what's happening, what you can achieve in the near future, and is your system scalable to adopt to these upcoming enhancements in these technologies. So you don't need like a large team of engineering internally to be really able to benefit from these um, advancements, I would say, in this technology. But you can just simply it's basically you need to have a bunch of smart engineers who take the right decisions and be at par with what's happening in the industry.
So we've talked about the revolution that this technology, in terms of data technology, has brought about in terms of, on the technical front. Um, what about data and governance? When I built a data platform in the past life, I would spend a lot of time dealing with different business units in terms of data definitions and things like that. What changes do we see now, Saurabh, in terms of how to manage that?
Yeah, so I think one thing which is happening and which is one of the focus areas as well. My team does it day in day out is like defining standardization. So there is a lot of focus on how do you how for our customers, like how do you focus on taking them to one unified view. Now I can understand like with different groups there are different nuances across different groups, but the core data model, the data lineage around it, the data catalog, defining a core standard is has become like an important element and a core foundation for setting up a scalable data platform. And once you have that, then you can get all the benefits of like every all the benefits that you can get on the downstream consumption, on the downstream usage, that just comes along with it. So I would say the most important aspect is the data modeling, one unified data model with possible different extensions to it to service the different needs of the user groups or the business lines that you have. But the foundation needs to be really solid, which comes with the core or standard data model.
Oleg, but I think part of the changes with modern ETL tools is I don't have to necessarily change my systems of record. Can you talk to that?
Uh, yeah, so I would say, if you think about your data as data products, then you can have baseline models and data products. And we suggest, for example, to organize your data products and share them through data domains. Then any organization, for example, financial enterprise, can have a reference data domain which is shared with other organizations or other domains, like investment management, which can add attributes or use this data model and extend it, and then share investment data based on this domain. And it all comes to data catalogs and sharing data between different organizational units, and creating even more derived products without re-implementation of the same things, right? And without redefining the underlying data models and data in domains.
Yeah. I think of this. Well, the analogy, whenever you think about the government is a great analogy here, where we have kind of the federal interstate highway system, which is the model. And then each of the states can run roads and run their local businesses quickly. Rather than unifying the whole country, we allow autonomy in the domains, and I think that's really good because it allows you can do a couple things. A, you don't have to boil the ocean. B, you can do one domain at a time, and it makes a lot of sense. So, Rob, what about organization? What kind of organizational structures? How are people doing governance in this new world? What do you see?
So I think the way they are structuring governance, they have, again, they're trying to align with the business lines that they have. So again, the complex organizations have too many business groups. So more or less the governance is aligned to the business. Like once you have the core data models, then your governance can really be aligned to your different business lines. So um, groups that needs to have access to the specific data within the organizations are structured to have those access, and today there are tools that can really do that well for you. So you have out of box tools that can really structure your governance needs in your core underlying data models. It could be your, as you need your organization is set up, you can define those access patterns so that you have the right access to the right groups, and you are well you don't have any concerns around like people have access to incorrect data, or uh, they are using or they're abusing their usage rights to see the data that they're not supposed to.
Yeah, let's think about integration. How are you guys seeing integration between legacy, bringing the legacy data in? What techniques are you seeing to do that, Oleg?
Yeah, so there are different technologies exist that allow you to implement data virtualization or data sourcing through APIs or organize like private tunnels to your data. And I would say this um, as any decision in designing of data platform or data workload, modern technologies or existing technologies allow you to pick the right technology for your business case. So, for example, if your business case needs very frequent access to data and large data volumes, and let's say if this legacy data source still locked in your data center, then you probably would need to initially copy and then synchronize your data to cloud store with CDC for faster access. But if it's in frequent access and like all this integration will just add additional cost and money, you can just can use something like federated query, lightweight integration that will be querying your data in your legacy data store and bringing your data back to your business application or data workload.
Right. So a couple things I'll comment on. CDC has changed data capture for the uninitiated, and the other thing is we always have to be conscious of the speed of light. If you want your data to perform, your queries have to be close to your data. Although with virtualization and caching, there are ways around this, but the speed of light is often a limiting factor, and data gravity is the term in the industry that's very popular now when people talk about that. And then obviously when we do this on the cloud, we have egress and ingress costs to model that keeps us honest. So Saurabh, we've got data coming from all over the place. How do we keep track of lineage in one of these really complex environments?
So again, there are tools that offer this today really well. So when you have your pipes moving data from one place to another, at every step in the process, you can have these pipes really capture the lineage information, so that when there is a need to really go back and see how the data got transformed from one source to another, what kind of normalizations led to a particular data value, you have like a robust lineage that can track you from point one to point two and so on. So the tools today that exist even capture or embed the data visualization or the BI capabilities are also embedded within the lineage itself. So right from the raw data to, let's say, the gold layer, or like the more data product, to the eventual semantic layer, how you see an aspect or element of the data, you can really backtrack how the raw data or the source looked from that. So there is like, you just need to have the right tools that can capture this information, and once you have it, you can capture the record level, or the even you can capture even the attribute level lineage using these smart tools that exist today.
Can you talk about time travel and or bitemporal data, whatever we're calling it these days, and explain why people need that?
So I think the bitemporal data is the need of the hour. It's basically the as on and as at, or as of and as at. People call it differently. But it's basically captures the two dimensions. One is the effective date for which the data is changed, and the other is the knowledge time when the data has changed. So when you talk about like auditing, when you talk about solving for what happened to your data, these two dimensions play a crucial role. We are in a world where it's all append only. You don't override the data, so you need to always capture these two aspects of how your data is changing, so that you can go back, you can see the state of your system like 10 days back or a month back, and you can recreate the same state. That has become an important element, because you need to be able to do that to be able to see like how your system looked at the time. And also you need to be able to see the effectiveness of like when this particular value started to take effect. Like people can change it today, but effective as of 10 days back. So those two dimensions play like a crucial role. And all your data models should be designed in a way that they can capture these two aspects of the time dimension, so that you have a view at any point how the data is changing.
Oleg, I'm going to ask you, I'm going to use the AI word. Can you talk about lineage and time travel and how important they are for AI?
Uh, Basically, with time travel, you keep you have records about how your data was changing, right? And with lineage, you have explanation of all transformations that produced that data. So basically, both of them uh, play a crucial role in building business user trust to data, right? Because normally when you look at some number, you may have doubts. So let's say you rating analyst or investment analyst, you need to understand how this number was produced. Then all these bitemporal systems and lineage systems still very technical, right? So you cannot just provide access to business user and think that he will take a look at all this big diagram and understand the origins of data. But when you feed the same data to AI and ask specific business questions, then AI can understand that data and it kind of accelerate time that is required to understand the origins of data and how it was produced. So with that, both capabilities very important, because in the end they create the business trust to data. And I also would like to add that when we're talking about lineage, there are two kind of aspects that you should consider. There is lineage data that we believe must be stored in open formats like open lineage format that AI understands very well without presence of any data visualization tool. And there are many visualization systems. So some visualization systems that show you lineage data, ideally they should be separate. So you should make sure that you, as an organization, have both access to data to enable your AI capabilities in the way you want, and separately provide users with visual interface.
So we started talking about AI. Sourabh, what kind of use cases are your hedge funds and asset managers looking to do with AI with this type of data?
So I think the AI is replacing many of the things that were done with software engineering a few years back. And all the analytical. If you talk about the hedge funds, they're trying to do the trend analysis. That's like a classic use case that AI is trying to do it more efficiently. They're trying to do their position change or analyze their position changes year over year, how their portfolios are performing, the trends between how their profits are, what's leading to a better portfolio structure. So basically, like all the trends around portfolio monitoring, and that's the focus of the asset managers, the hedge funds, so that they can invest into like areas where they are performing better, and where the portfolio is trying to give them better returns. So that's like a classic use case which I see the portfolio managers or the hedge funds in general are really focused when it comes to utilizing the capabilities of AI, ingesting, as Oleg said, like the entire lineage or entire history of data that you can give to these LLMs, and they can generate these trend analysis insights into how to better make use of these to invest into the right areas. So that's the focus of the prime hedge funds that I see being one of the more focus areas.
Oleg, can you talk about your work with the AI Lake Accelerator Framework and rating agencies, and give an example there?
Right. So AI, other than improving human productivity, other than providing natural language interfaces and streamlining data integrations and data processing implementations, it also unlock access to the data that you haven't automated through your data pipeline. So for example, with a RAG, you can just upload documents to a common storage, and they will be indexed, and with a simple agent on the top of it, you can have access to this data. So for example, if you are rating agency analyst, you can just ask your questions about any supplemental data that was not extracted from the filings, and you will have data supporting your analyst judgment, right? But on the other hand, you also can, and that will be access to data that never was extracted with your ETL tools, right? It unlocks access to data. But on the other hand, you through AI agents, you also can query data in your structured, well-processed, and validated data sources, and source this data in your official models with lineage and traceability, and make your judgments based on stamped data that pass the quality standards and provides data of good quality.
You mentioned RAG. Can you explain RAG to the audience?
Yeah, it's a simple technique when everyone has access to ChatGPT and can ask questions, but ChatGPT does not know anything about your data. What you can do, you can implement a lightweight indexing process when data is extracted from your unstructured data source like PDF document or text document automatically and becomes searchable. Then you integrate it with the agent, and now when you ask agent any questions, it can search for data in this specific data source or set of data sources if it's a chain of agents, and then it provides you answers based on this data. Data source does not have to be unstructured, so it could be your warehouse or relational database. Agents these days can query data and actually unlock data because business users now don't have to ask IT to write specific queries and reports. AI agents are capable of generation of such queries with complex join based on user prompts and bring data back in a secured managed way.
So, Sourabh, can you touch on your thoughts on that?
Yeah, so again, as Oleg said, so this is one of the capabilities where you can get better performance from these LLM tools. You basically provide the reference data, your entire history of the data that exists in your organization as an input, in addition to these LLMs trying to uh, respond, or these agentic workflows trying to respond on generic commands. They can refer the data, or that's basically the RAG technique. You provide that reference access to these tools so that they can really be able to respond or react to based on that underlying data that you provide additionally. So it basically improves the accuracy. It basically, they can do more, and it helps to bring the productivity, or increase the productivity of the organizations by using this capability.
Yeah. Yeah, a couple of AI comments. One comment to me is there's two classes of AI work we're doing here. One where we're using AI to generate things like sentiment analysis, where if it's 74% of the people like something instead of 78% of the people like that, it's not a problem that's necessarily going to kill us, versus something like with a drug or a financial transaction where it's got to be right, it can't be wrong, there can't be any hallucinations. So obviously we're seeing both types of use cases here, and we just have to always keep track of accuracy. Let me ask you each, sir, I'm starting with you. One final recommendation for people to think about and take away out of today.
Yeah, so what I would say is times have changed. This coming up with like, or data is power, but making use of data, the times have gone that you had to invest years and multi-million dollars to be making efficient use of the TBs of data that exist in your organization. It's a much easier project now by the technology that exists, or making the efficient use of the technology. You need to be choosing the right tools. The user base is important. You need to be bringing them at the right stage, not like too late in the game before. Um, and also the more important thing is setting up the foundational data models correctly. So I think once you do all of these things right, you are bound to make use of all the AI stuff that we have been talking about, that can really bring up your productivity. So once you have these foundations right, I think it becomes much easier to really be able to, and again, I missed one important thing, which is data quality. I think having clean data, which is again a capability that many tools provide now, when you're running your data through various pipes, at every step you need to ensure the data, the required data quality, which again, like, it's a cyclic thing where AI can help you do this, but as long as your foundation is strong, you can then benefit of using, or you can benefit using all these capabilities on top of it. So that would be my advice to people trying to solve this problem in the organization, and that is a focus area that you should start with.
Yeah, data quality. We really didn't touch on that enough. Oleg, why don't you talk a little bit about data quality, and then give your one takeaway for this talk.
Yeah, the data quality is just a must-have component of your solution. It should be very easy to set up data quality checks based on like human expressions that and it could be easily understood by humans. And again, coming back to open standards and to data availability, you should treat your data quality output, such as results of execution of data quality and data quality metrics per data row, as another valuable data asset. Also available, of course, for AI, for explanations, but for visual exploration too, right? So these components have to be in place. This is crucial because, as we said before, garbage in, garbage out, right? Without reliable data quality, you will not be able to get reliable results from AI, and you need to have this capability.
Now, Oleg, can you do one takeaway for people?
I fully agree with Saurabh. But another thing is, like, we see many requests today, like, which are the same like in the past. Hey, we want to build a data warehouse. Which technology we should use? I would say think about the future when you building or enhancing your data platform. You are not building your data warehouse anymore. You're building your future, like, virtual AI workers and your and your future AI platform. So ask questions about how my request today will be aligned with the architecture and capabilities in the future. And with that, I would say, don't ever think about implementation of monolithic platform that can satisfy all requirements up front, because you don't ever know what requirements you will have in the future. Build it modular and build it as much as possible using open standards. Be ready to retire certain components tomorrow, bring in new components. So that should be like your guiding principle.
Yeah, I think that's a great one. I'll use that as mine. I think the AI stuff is moving really, really fast. There's all sorts of new things coming out of it. But by building a sound data platform, you can take advantage of the new stuff coming out of the AI platforms very quickly, and all the work being done by many people. So and once again, the other point I would make here is that we used to do these kind of data platforms for a competitive advantage. I think now it's gone the other way. If you don't do this, you're going to be at a competitive disadvantage because the cost of entry has gotten so low. And I think that's my last takeaway. We do have we have time for one question, so let me put that up, or a couple questions, guys. Both of you. What is the common mistake you see, Saurabh? Something to avoid doing. We've talked about what you should be doing here.
Um, So I think one common mistake that I have seen, again, I touched upon this before as well, but bringing the user group too late in the game, that and Oleg's point is really important about trying to build like trying to come up with a system that becomes usable 2 years down. So those are the two common mistakes that really put you under a big risk. So you need to have like much smaller milestones. You need to have quicker time to market. Something should come out like every month or so, so that you can start to see what's working, what's not working. I think that's one, especially with big organization, that tends to happen where you have like much larger milestones. You try to define something like 1 year later, like how your setup should look like, which is like at times a disaster for recipe, a recipe for disaster, where you just don't bring the right people and or have some people try to use the platform that you're building for a year, and then you realize there are some core components that were not fitted properly. So those are the areas where we see like the organizations tend to make certain mistakes when dealing with projects like this.
Oleg, same question.
Yeah, they like it's very easy to come up with prototypes and be excited and think that you can move them to production, but without I just repeat what Saurabh told before. Without like foundational capabilities, even if they are very lightweight, maybe not very mature, such as data lineage, data quality, you will not be able to have reliable output. So have some foundational platform in place, and start from the foundation. So don't go just with quick prototypes without this foundation, because they will increase your technical debt, right? And you will have to solve the solutions down the road.
Okay, one last question. We have a bunch of legacy systems, we all do. If you had to pick one technique that you like best, change data capture, APIs, virtualization, which is your favorite? And uh, obviously you have them all in your toolbox, but do you have a favorite, Saurabh?
It's a very tricky question. So there's no one thing that just works, right? Like it really depends on your use case. Um, and it depends on your usage pattern, right? So I think Oleg did mention this previously as well. Like if you have like a virtualization, if let's say virtualization is possible and you go with it, you have a federated system, there could be times when that really doesn't work as good as you actually doing CDC. And again, these monolithic systems or legacy systems, if they're not capable of doing CDC, then that becomes a challenge for you. The federated queries do have like their goods as well as bads. Like you can imagine a world where you get a lot more data, and then trying to join once you have all the data from underlying legacy systems, it can lead to like more time that these queries would take. So and API is like, again, that's a way to really do stuff scalable faster. But again, we know like there are challenges with APIs as well. So I don't think there's like one good answer to, okay, you need to go with this. It really depends on what you're trying to build, what is your end result, what you're trying to solve for. That really determines what should your right solution be.
I think you're saying in some ways it's art and analysis versus science versus choices here.
That's true.
And yeah, interesting. Um, Oleg, any last thoughts, and then we'll wrap this up.
Yeah, I would ask another question. Why do I have to choose one solution? So usually business or organization does not care whether it's one, two, three. They care about the cost of implementation, how easy it is to do, and any of the solution relatively easy to set up. But then the question is like, how much technical debt you will build on the top of the solution. Are your plans then enhance functionality and even increase dependency? So this perspective, cost and tech debt, I think is very, very important. As a tactical, you can do anything. I like both CDCs or federated queries, for example, right? Easy to set up, and you can stand up your read-only replicas very quickly and start accessing this data. Just to think about one step ahead, and also project all these things that I mentioned, plus your future migration strategy, how much efforts and money it will cost, and when you will be retiring these technologies. And I think that should help to answer questions.
Well, great. Well, thanks everybody. I think this was really a fun discussion, and we'd love to hear from you with your questions, comments, and we'll try to do another one in a few weeks. Thank you so much.
Thank you.
Thank you.